So, dear all, as I promised in the conclusion of the second part of my analysis related to the tram derailment in Sarajevo, uh, there is the third part, the third one, where I try to give one graphical representation of that what actually happened, in my humble opinion. Uh, this drawing actually is a part of the drawing that you are going to see very soon on your screens. This drawing is actually part of the official is-built design documentation. Is let's say absolutely available document which is in the possession of the many project participants and also tens of members of the technical committees performing the technical taking over procedures and a couple years ago, and also the that's absolutely not the secret. So I wanted to use one original document, and I used it a couple of days after the accident to make the first information, the first report about it, and also my first theory. I also will give you opportunity to see the track alignment of of this tracking subject, and also one excerpt from one larger video record I made also couple days after the accident, and where I wanted to show how the tram and road signalization, traffic signalization, sorry, functioned in this intersection point in this section area, in this approaching zone from the railway station direction towards the Triangle Technical School. Now now I hope you can see this drawing, which is once again to say a part of the eligible documentation. So represent one official and publicly available documentation, authentical document on which we can see in detail and analyze everything that we want. Uh, Taking into account mutual distances between three wheel sets of this characteristic tram vehicle, as well as distances between their wheel pairs, also that means the axles inside wheel sets. Several characteristic wheel sets and individual wheels location I have observed. Actually, it's absolutely evident. First of all, to say that the first wheel set and passed through the almost through the whole intersection and this track. Namely, it started from the turnout number 5, which is a standard turnout 50 to 25 meters radius with rails R60 R1 in the deep groove crossing. Then the crossing number 3, also in the deep is in the deep groove. The crossing number 3, where you can see from the drawing also happens this transition from the tangent track through the straight part of the turnout and the track curved track in the radius of 25 meters. Where you can see also where it exactly starts this radius 25 meters, and then you can see also the intercrossing, let's say section of 15 meters with the normal, let's say normal race 60 R1, also deep groove. Then you can see also the flat crossing number 2 with both ramps, all ramps in all four directions. Ramps for 1,200 millimeters. So I spoke about in my previous announcements, and including let's say these ramps, and also the vehicle passed even this through this crossing where as we know, as I mentioned in the second, the first and second part, where we have the climbing, let's say the change of the groove depth from the 47 millimeters to 14, then after the passing through the crossing from 14 again to the 47. That also that was the part where the vehicle passed through, and also the biggest part of the turnout number 4 actually two-third of the this part. And according to my analysis, the derailment of this first wheel set happened and occurred in just couple, just 4 or 5 meters before this turnout, let's say, beginning, uh, or 8 meters from its end point. What is the first caught my eye was the subject of my, it was also subject of my analysis, was the distance between the point of the first wheel set, better to say the first right wheel, because the tram was tilted, and then everything in general, particularly the first wheels were on almost all the time on the right wheels. Uh, the first right wheel, when it enters the turnout number four crossing point, crossing location, crossing area, where as we know, the, the guiding is not absolutely interrupted, but uh, shortly also, let's say, we say interrupted, but not completely, but there is the gap there. And but when it comes to this crossing area, uh, and the position, you can look at the position of the second and third wheel sets at the same time. And I saw that location of vehicles wheel sets was designated. I made a designation of these wheels. I'm presenting here five positions of the tram along the curve, along the track. And most important for me are the positions uh, 2, 3, and 4. But in the possible next upcoming uh, presentations, we will maybe speak also about the first one. But let us. I designated it with the WS, and WS, of course, wheel set one, wheel set two, wheel set three, but also the vehicle position 1 to 5. Uh, you can see on this drawing. It's namely now to see that the right front wheel of the wheel set number 2, at the moment when the front wheel of the first wheel set enters this crossing zone of the turnout number 4, is almost directly in front of the one of very of four flat crossing. I say the flat intersection, let's say, tracks points, because all such kind of crossing has four parts, four areas, which are the crossings between the two tracks. And it's just in front of one of four these crossing. This is crossing this wheel number crossing number 2, the second crossing point, looking from the direction of the vehicle driving, running. Just behind this point, you can see that the clear derailment trace on the outer right wheels sides. You will see better on the video. This is one straight line. It's very visible, and it goes up to the track, up to the eastbound track, Elijah Bashashia, up to the its left rail, the first rail, and from which is also you can see there is a second trace as a result of the tilted wheels sudden turning to the horizontal position. This second part of the vehicle. The next vehicle position that caught my eye was a position of the wheel sets WS3. I named and I designated. That's a state that position where the first wheel set is still inside the track. It is already tilted severely to the right as a result of the high centrifugal force. But the right track of the wheel set number 2 at that moment is already in the contact with this previously mentioned right track of the double track religious Bashashia, since the right wheel of the third wheel set and the front one is just in front of the tip of this next, the very first flat groove crossing number two. This is where we have also, of course, the depth of the groove only 14 millimeters. Behind this point, in the direction of the third wheel set moving, just behind this crossing point, this intersection, let's say this intersection of between the tracks inside of the crossing, you will see also in the video the derailment trace which is visible. It all goes again up to the this eastbound track Elija Basharshia, up to the its left and right trail, and the trace is there, very similarly like in the case of the wheel set number two. It needs collision with this the same track. Between the rails of the right track and of double trim line Elija Basharshia, between these two rails, these eastbound tracks, are visible also traces of the outer sides. There are different traces. Also, you can see that as a result of the track moving back to the horizontal position, we can see also the traces of the flank and also the outer outside this part of the outer side, let's say, of the wheel. Maybe also there is some deformation of the wheel itself inside. Some we call uh, uh, hollowed uh, wheels, but I don't want to speak about that because I'm not sure about it. And even the outer side and the flank itself can make such traces. Behind the right rail on this main track, we can only see the traces of the flanks since the second vehicle part returned to the horizontal. And this scenario in which the first wheel set comes, it comes to the transition turnout point from radius 25 to 50 meters. Maybe not doesn't have to be the distance, but it's in a way very evident, indicative. Uh, and this is approximately 20 centimeters before the switching end of the turnout switching point, looking in the vehicle moving direction. Let's say from the turnout endpoint some 7-8 meters, and in which the second vehicle part is already brought to the brought in a turn horizontal position. It resulted with final climbing, how to say. It was climbing and derailment of the right wheels of the first wheel set on a very short distance in a very short millisecond time, seconds time and time period, and it on the distance of, let's say, 3-4 meters, and the first wheel set derailed, returned sharply to the horizontal position, and fall down to the into the pedestrian zone with the decorative elements. You will also see on the video, leaving there visible traces, particularly by the left wheels, and it continued moving over the tram stop up to the stop point, and the second wheel by inertia continued moving along this very pretty long asphalted area between the intersection between pedestrian crossing intersection itself, parallel road, and these curbstones you will also see on the video, and up to the stop point in the tram stop just behind the pedestrian crossing. This is now after this explanation, I'm giving you the one excerpt taken from the video record. I made a couple of records, made video records, and this is the excerpt of one of them, made a couple of days after the accident, and from both directions I made it, but this one is only from the direction in which the vehicle was uh, in which vehicle ran. Uh, I also made some snapshots and analyzed these traces, etc., etc. But uh, this video is something that shows you. You can see this what I was just spoken about. This is a uh, you can repeat. I can repeat your couple many times, and you can slow down. Make it's like slow motion, and look at in detail, and agree or disagree with my opinion, etc. In my previous, in the second announcement, I pointed out also a very short time that the trams have to pass the technical school intersection when diverging from railway station towards the center of the city. And please look now carefully one excerpt from one larger video record I also made a couple of days after the accident. And the video was made in this, let's say, how to say, real time. But I took it a couple of days after the accident, I cannot be, that doesn't, I must not be 100% sure that the same traffic regime we had at the time when accident happened. But looking at the situation now, after a couple of months, I'm quite sure that it's not much different. So at the end of this, let's say, third analysis part, I want to initiate something very important, which can be also connected in the future also with this case, but at the moment doesn't have the direct connection with the fatal event that happened in Sarajevo, but which can be had to be considered also before the reconstruction, during the design phases, and during the works, after the works, etc., and during the maintenance period, exploitation, etc. Namely, it's about the trying to draw a parallel between two derailments, which is almost which is very difficult, mostly very difficult to make. But it's very indicative that indicative. Okay, it's maybe wrong word, but it's very interesting that the two derailments, the trend derailments, are not so doesn't happen so often. But in a couple of weeks, we had the two derailments in Sarajevo and in Milano. And I tried to look at it. I try to make some parallel between them, but it's correct me if I'm wrong. Since information that I have about Milano accident, I took actually by researching number of articles related to Milano rail tram network in general, and with a very specific gauge of 1,445 millimeters, which is 10 millimeters wider than the standard gauge 1,435, which we have in Sarajevo as well, which we have in Sarajevo. So the track geometry there, where is the parallel? We also have some west-east tram line. This is tram line number 9 through I think, the street Viale Vittorio Veneto, which with one divergent track to the north, to the north, yes, I think to the north, in the or south, sorry, south, in the street Via Lazaretto. And there is some similarity between Sarajevo and west-east double track main line and the divergent tracks. Only if you imagine something like this scenario. Look at the line Sarajevo in Sarajevo. And imagine that there is no at all this diverging toward railway station. So there is no triangle. You have only double track line, and from the direction from the westbound track, the direction from the Bastarcia towards Ilija, you have some divergent track, single track towards the south. This is the part where we have the museums in Sarajevo and let's say towards the south, one single track, whatever it is. And this track has to cross the eastbound track uh, in one point. Train traffic in the Via Vittorio Veneto street is extremely strong, and Via Lazaretto street I heard served only as a technical, let's say, the emergency diversion, or uh, how to say, the track which is used only to uh, move the vehicles due to some accident or some reroute. just the vehicles due to some accident on the main line, or because of some problems on the vehicles, etc. What is the analogy in these two situations? It lays. This is of course not the analogy only if you imagine this scenario I explained before. The analogy is in the fact that on all occasions, in such cases, the installed crossings with this eastbound track with flat grooves, both as far as I know. Of course, Sarajevo was in that case also a flat groove. Due to crossing angle, of course, for example, I'm sure that in Italia also, as in Sarajevo, the flagway analysis was performed, and it resulted with the flat grooves in both cases. Once again, correct me if in Milano there was not the flat groove. That what in both such similar cases happens is extremely big difference in the flat groove varying development speed in tangent and the diverge direction, which is in very which is mostly in a very short exploitation periods, leads to some I call it like a staircase inside of the crossing. If divergent tracks are rarely used, and in Sarajevo is let's say divergent track rarely used. In Milano, most probably maybe not used, maybe yes, I don't know. If they are not maintained by regular grooves cleaning, if regular build-up welding is not performed, and build-up welding is not performed in all the region of the West Balkan, all four cities that I know, I guarantee that never and nobody made, never anybody made the build-up welding to keep the rails in the form, in the shape, to enable the dimensions prescribed by the TRSP inside of the limited values. But about that in some of the next upcoming uh, uh, upcoming presentations. What I wanted to say by this in these such situations during the long time exploitation, even not after several months, it can happen, depending on the type and kind, on the harness of the rails and of the wheels and rail and the superstructure type. It happens that you have there possibility that even by the normal speeds up to let's say 15 20 kilometers per hour, you can the derailment can occur, can happen. In this context, due to the existing of the flat groove part, it remains me a bit unclear why the speed in the approaching appropriate in the this crossing area between Viale Vittorio Veneto and Via Lazaretto, uh, this complete part wasn't with the limited speed, because we obviously there is the turnout there is the crossing with the eastbound tram, and it's in my opinion was necessary to have some, but of course again and once again please take my apology if I'm wrong and if I don't have the appropriate data, but this is important for Sarajevo. I'm talking that in both cases that is something which is very important. It has to be checked. I'm I know why I'm talking, but and it will be the issue for my one of my upcoming uh, analysis. For both cases, in both cases, we have also theoretically possibility that that the vehicles roll over. And with maybe most probably much more much worse consequences that could have happened. In Sarajevo, all over was prevented by the low weight position point position of the it was empty tram, almost empty, much lighter vehicle, and also this horizontal moving of the this moving of this lurching of the second part of the tram brought back the front part, the horizontal position, and prevented this lurching. And in Milano, on the other side, on the part of the tram was the building where it stopped, but also maybe, and it's not excluded, that also the turning, the during the derailment also happened on the crossing, and that also these axles and these wheel sets, the rear wheel sets of the Milano tram vehicle contributed also to prevent the rollover. It, there is now another issue. It's everything very connected. We have completely different scenarios. In Milan, for sure, we have the new tram on possibly relative good and quality line, even maybe also the Virgin track. I don't know. Okay, we have new, absolutely new, the newer generation, the standard generation than in Sarajevo, and on the other side you have some, let's say, regular line. In Sarajevo already also you have the infrastructure which is relative new. A couple of years, 2 3 years ago, it was built and is under exploitation. Uh, and old vehicle, but uh, always we have to we have to keep in mind that the new infrastructure doesn't mean the proper and good infrastructure. The old vehicle doesn't have to be and to mean the bad vehicle. Everything has to be matched. Everything has to be measured. In Sarajevo, for example, immediately after the accident, during this investigation, this is the same in the railways. Everything has to be measured. Everything, all important things have to be measured on the rolling stock, on the railway, on the superstructure, uh, the weights, all necessary measures have to be taken. And but for sure, also by the old trams, we have to calculate with the some, let's say, uh, bad parts or some problems with the wheel set, some, let's say, bigger or higher possibility of the lateral movement of the not elastic an elastic movement of the axles, of the wheels itself themselves, etc. Uh, Also, the let's say the disposal of the wheels along the tram are important. The wheels that doesn't have to be do not have to be do not have to be the same diameter, but they if they are properly and correctly disposed along the tram vehicle, it can also play a big role. For sure, this is some just now opening of the next items, issues, and which it will be the subject of the further analysis. So at the moment, I will finish with my third part of the analysis, and uh, I do hope to continue with that. All comments are very welcome. Uh, all comments or your suggestions, even if you agree with me, if you do not agree with me, particularly if you do not agree with me, please be very, let's say, you appreciate it. You are welcome to give your comments and improves, to give your theories and etc. Because only together we can come to the final result, the final analysis, and the final conclusions to prevent such cases in the future. So that's for the moment uh, from my side. Uh, I hope enough, and I want to thank you for your attention. And I can just say, have a nice time. Yours faithfully, Sadia.